Hi, I'm Ryan Baker, and this is Big Data in Education, Core Methods for Educational Data Mining. In this MOOC, you're going to learn methods used for exploring big data in education. There are two research communities that are currently working on doing this. The first one is the Educational Data Mining Society, which has been around in one form or another since 2005 and has been holding conferences since 2008 and publishing a journal since 2009. And the second is the Society for Learning Analytics Research, which has been having conferences since 2011 and founded its journal in 2012. These two communities have a joint goal of exploring the big data now available on learners and learning, to promote new scientific discoveries and advance the science of learning, to promote better assessment of learners along multiple dimensions, not just what do students know, but also their cognitive, social, emotional, metacognitive dimensions, and also not just looking at individuals, but looking at groups, institutions. And finally, to do all of this, to provide better real-time support for learners. In the words of the former editor of the Journal of Educational Psychology, Art Gracer, educational data mining, learning analytics, is escalating the speed of research on many problems in education. Not only can you look at the unique learning trajectories of individuals, but the sophistication of the models of learning goes up enormously. In the words of another person talking about educational data mining and learning analytics, EDM is great. Despite the area's newness, we've learned a few things about key problems. And this course is about methods that have been found to be useful for those problems by researchers in educational data mining and learning analytics. Where do the methods come from? Some of the methods we're going to talk about in this class would be familiar to somebody with a background in data mining and machine learning. Some of the methods would be familiar to somebody with a background in psychometrics or traditional statistics. You don't have to have either of these backgrounds to get something out of the course. Pick and choose what you find most useful. A few words for data miners. You'll find that there are some current trends in data mining that aren't really represented in this course. Some of those haven't gotten here yet, and some of them haven't been very useful yet in educational data sets. I'll be focusing in this course on the methods of broadest usefulness for educational problems and not on the methods of coolest newness. A word of note, just because a method is more recent or produces more complex models doesn't mean it's better. With complex real-world data, more complex approaches can often overfit more to the noise in the data or the biases in the training sample. This isn't a problem if your training sample is every single person ever to have used Google, but it can be a problem in data sets of 200 or 300 or even a couple thousand students. Another word, what makes data big, since this course is called Big Data in Education? Laney talks about the 3 V's. There's a later writer who talks about the 4 V's. I kind of like to get to the basics. First, volume. How much total data is there? Second, velocity. How fast is the data coming in and how fast do you have to handle it? And third, variety. Often data has incompatible formats, non-aligned data structures, and inconsistent data semantics, where the exact same data can be represented in different ways in different parts of your data set. Any one of the 3 of these can make data hard to work with. Education often has especially much variety, and the volume and velocity is going up as well. Another comment, is educational data big? Well, it all depends on how big we're talking about big. Take Google, that's the mountain in the distance. PSLC Data Shop, which is probably the largest source of educational data at the moment, tiny little pebble up there. And then you might say, why am I saying our data is not that big? The name of the course is Big Data in Education. Well, big data in education is big. It's big by comparison to most classical education research, and it's big compared to the common data sets in many domains. In fact, when the KDD data competition, which is often considered to be the largest competition in data mining, had an educational data set a few years ago, the educational data set was the largest in the history of the competition. Educational data is big, but it's not Human Genome Project big, and it's not Google big. It is big enough, for example, that traditional methods for education often fail. Statistical significance testing. People have found differences in R-square of 0.0019 to be statistically significant. If you don't know what that means, don't worry about it, but it's a problem for using statistical significance as your criterion. You have to use other methods. I'm going to talk about statistical significance sometime in this class, especially in the lecture on correlation mining. It's not going to be a focus of this class. And also, statisticians beware. Terminology sometimes conflicts between stats and data mining. I'm going to highlight particularly annoying cases where they emerge, but keep in mind when you hear a bit of jargon, it might not always mean quite what you think it does. There's a great range of types of educational data mining and learning analytics method. The first of the broad methods is prediction. Develop a model which can infer a single aspect of the data, what we call the predicted variable, from some combination of other aspects of the data, the predictor variables. Prediction modeling can be used to infer things like which students are off task, or to predict which students are going to fail the class. We'll talk about that this week. Structure discovery. Find structure and patterns in the data that emerge naturally. In this case, there's no specific target or predictor variable that you're looking for, unlike prediction, but you're trying to find out what patterns emerge naturally. Relationship mining. In relationship mining, we try to discover relationships between variables in the dataset with many variables. Discovery of models. In this case, we take a pre-existing model, developed using perhaps EDM prediction methods, or clustering, or knowledge engineering. We apply it to the data, and we use it as a component in another analysis. So why now? Why didn't EDM emerge in the early 1980s like bioinformatics? There's a lot of reasons. One of the key ones was that for a long time, there wasn't enough data. In the 1980s, collecting educational data was highly resource intensive and it was difficult to scale. And a lot of the data that was easily collectible was purely summative in nature, standardized exam scores. Getting data on learner processes and learner behaviors in field settings, in real settings where learning was occurring, required methods like quantitative field observations, video recordings, think-aloud studies, none of which scale easily. Fast forward to today. There's still lots of standardized exams. They're still summative in nature. But now lots of students use internet-based educational software in class. This can be used to get at learning processes and learner behaviors at a fine-grained scale. We can log student behavior at a second-by-second level and see how the processes unfold at that speed. And data acquisition can be very scalable. We can get data from tens of thousands, hundreds of thousands, even millions of learners. And there are these things called MOOCs, which you may have heard of. A decent chunk of that data has, over the last several years, ended up in something called the Pittsburgh Science of Learning Center Data Shop, also now called LearnSphere. The Data Shop is the world's leading public repository for educational software or online learning interaction data. It has over 250,000 hours of interaction between students using educational software, with over 30 million student actions, responses, and annotations. This includes things like students entering an equation, manipulating a vector, typing a phrase, asking the system for help. It also includes the system's responses, like feedback on errors or strategic hints, and it's annotated with things like the correctness of student actions, how long the actions took, and what the relevant skill was. Now there's a bunch of tools for data mining that you can use, and a bunch you can use in this class. RapidMiner is one tool that you'll need to learn in this course. I picked RapidMiner because it's accessible to non-programmers, and it has a large proportion, though not all of the power, of Python or R. There's also a walkthrough with instructions for getting started on the course website. So a few closing thoughts for this first lecture. Educational data mining and learning analytics methods are emerging for big data in education. In fact, in a very real sense, they really have emerged. In this class, you'll learn the key methods that people use and how to use them to promote scientific discovery and drive intervention and improvements in educational software and systems. We'll also discuss the strengths and weaknesses of methods for different applications, and we'll help you try to answer the questions, is your analysis trustworthy and is it applicable? Thank you very much. I'm Ryan Baker. This is Big Data in Education. See you next lecture.